So, welcome to my class, and today I will be talking about numerical taxonomy. So, this is an interesting field, but in recent searches, I have found that this particular field is not being studied anymore. It is studied very less. Now, this has been overtaken by another more better field known as cladistics. However, numerical taxonomy still has got its benefits. Now, I will uh, go to a blackboard and I'll try to explain what this numerical taxonomy is. I have already uploaded my notes in the Google Classroom. You will find my notes and email materials over there. That should be sufficient for your exams. Okay. So the topic of our study today is numerical taxonomy. The word used is also nowadays they use this word numerical phonetics. Some people also call it as phonetics. So this is what it is. So there are two terms are used over here. The first thing is numerical and the second is taxonomy. Numerical always means counting. So you have something like numbers involved. And taxonomy, of course, you know, is the science of classifying organisms based on how similar or how different they are. So based on how similar or how different they are, the organisms are classified. So this is only called as numerical phonetics. And the chart which you find or the product, end product, that is also known as phenogram. It is known as phenogram. Now, numerical phonetics, a very important book of numerical phonetics, numerical phonetics or numerical taxonomy was from two scientists, Sneath and Sokal. So they had two books, one in 1963 and 1973. Here they had laid down all the principles of numerical taxonomy. So according to them, numerical phonetics, or calling them as NP, numerical phonetics, it can be defined as it is a methodology and methodology of assembling individuals into taxa on the basis of an estimate of unweighted overall similarity. This is the definition which you can find. Now, what do you mean by unweighted and weighted? So there are two terms which are being used here. One is weighted, the other is unweighted. This means, weighted means you consider, you give weight to if a character is important or not. You give weightage to if a character is more important. And in unweighted, you don't give this weightage. What you do over there, you just see the number, numerical values, and then on the basis of that number, you put your classifications. So, if two individuals, you see that they have got 10 characters in similar characters, and two organisms which have got only 4 characters in similarity, you will always say that these two organisms with 10 characters are more similar than the two organisms with 4 characteristics similarity. However, this is always not right or wrong. We will be talking about the merits and demerits. But in numerical taxonomy, we use these numbers. And the best thing is this is an empirical thing, and what you get is values from numbers, but numbers can be misleading several times. Now, there are certain terms which we must use, which we will be using. One of them is OTU, and this means operational taxonomic unit. So basically it means it is the basic unit in numerical the basic unit in numerical taxonomy. So what can be the numerical? It is basically, in simple terms, phylum taxonomic unit. You can call subphylum as a taxonomic unit. Basically, that is nothing but operational taxonomic unit is a taxonomic unit. Subphylum, then you have class, you have subclass, you have order, you have genus, you have species. So these are operational taxonomic units. So when you are classifying organism, operation means while you are doing the work. When you are classifying organisms, when you say you classify, you are comparing two genuses. Two genuses are two operational units, are two OTUs. So you are comparing two genuses, right? Your genus. So there you must always have a species, several species present. So two individuals of a genus of an OTU. There must be two species present. For example, you are comparing your two individuals of the genus Drosophila. So you must have at least two species. Say for example, Drosophila melanogaster or Drosophila simulans. You are comparing whether they have similar characters, how many similar characters. If they have got many similar characters, all the characters are similar, then of course they will be put in the same species. But if they have got slightly different characters, then they are basically put in a different species. But genus wise they are the same. So you basically make a comparison. How similar? So they have got 10 characters similar. So and what are the total number of characters which you are studying? Say it is 10 characters you are studying, and all the 10 characters are similar. So the ratio 10 by 10 is 1, and so it is 100% similar. So they are placed in the same OTU. Now you find that they have got say 7 characters similar. So the ratio is 0.7, 7 out of 10. So 0.7 and 0.7. So they have got a 0.7 similarities. They can be placed in different OTU, but the distance will be very small. That the higher the ratio you find, 0.7, the closer they are. 1, the closest. 1 basically means it's the same, and 0 furthest. They are the separate. So like this, they can. This is how basically numerical taxonomy works. Let us go to the next part of our study. And in this study, we will be studying among how taxonomy works, numerical taxonomy works, the principles of numerical taxonomy. We will be studying about principles numerical so they have two aspects. The first aspect of numerical taxonomy is you have to construct taxonomic groups. So the individuals in numerical, the individuals are selected and their characters are spotted out.
Sir, you're not audible.
I am not audible. Nothing can be done, unfortunately. Let's see. Let me check once more.
স্যার নেটওয়ার্ক প্রবলেম হচ্ছে
Okay.
Sir, the voice is getting distorted.
Okay. Let's see what can be done. I'm trying to change the network. Am I audible now? Hello? Hello? Am I audible?
yes sir
Yes.
Okay, let's go ahead. So the first thing is you construct taxonomic groups. So what you do here is individuals are selected and their characters are spotted out. So you select individuals and you spot out their characters. So actually there is no limitations onto the number of characters which you are going to be considering here. More the better. Of course, the more the better. And then you find out the similarities between these individuals. On the basis, you analyze these characters. Okay, they have got 2 ears, 2 eyes, their eyes are brown or something like this. You do their analysis, and then uh, you do this. And next is, after you construct this, then the next thing is discrimination between the taxonomic groups. That is, you find out whether these individuals are the differences. First you find out what are the similarities and make them groups, then you find out the dissimilarities, and on the basis of them you do. And now we will talk. There are basically this Neath and Sokal, they laid down certain rules. They laid down certain rules of numerical taxonomy or phonetic. The first, it is the greater the content of information, greater the content of information in the taxa which you're studying, or the operational taxonomic unit which you're studying, and greater the number of characters studied, what you have is, you have better, or the better the classification system. So more information, more characters you study, the better of course your classification will be able to classify better. More which you get, they are living species, if they are living individuals, that's not a problem. If their groups are there available, but if for example in fossils the amount of information is limited, so there it becomes a process, you don't get that better classification present. And you must give, very important, and this is also a drawback, this is also a strength, equal weightage must be given to the character. Each character, it must be unweighted. So you don't say that the size of the head is the most important character, the size of the tail is the least important character. No, size of head and size of tail, both of them are equal. You have to give equal value to them. This is a problem, this is its strength also. You don't make a bias. Problem is, sometimes you are very sure that this character, like even insects have got eyes, and humans have eyes. That doesn't mean that human and insects they can be placed in the same place. So but they are given an equal weightage. Okay, eyes present, eyes present. Well, this is a problem. But uh, whether it's an animal, whether eyes are present, it's an animal. Well, that's its strength. Since it has got eyes, it can see, it's its strength. At the same time, it's weakness. So at the every person's strength is every person's weakness. So the strength of this numerical taxonomic system is is its, we say, weakness also. Some cases this gives equal weightage, gives better strength. In some cases it is a drawback. Okay, now the overall similarity between any two entities is a function of individual similarities. So function of function of individual similarity in each of the similar characters, many characters. This is equal to or is similar to, this is the sign of similar to overall similarities. In layman's language, this means two taxa or two OTUs or two operational transcription operation taxonomic units. The similarity is basically a function or it is promotional. It depends on, a function means it depends on, individual similarities. So this taxa has got very lots of individuals, so each individual has got some similarity. So it is the all the sum of all the similarities and dissimilarities taken together. So if the population has got 100 individuals, so that 100 or if the sample has got 100 individuals, all the similarities are taken from 100 individuals and compared with 100 individuals of another taxonomic unit. So it is basically you're adding up all the similarities. Some people among human beings, if you consider nose, some people have got flat nose like the Chinese, and the Aryan race, they have got a sharper nose. You see, there is a difference. The Negroes, they have got thicker lips. We have got thinner lips. So basically, it's all the sum of everything. But still, all of us are human beings. If we compare all these our characters with that of another genus of chimpanzees, we will find the similarities and dissimilarities. This is what is the layman's language. So individual characters are added together to make an overall character, overall similarity. Individual similarities together make overall similarities. This is it. The next part which we will study is correlation of characters. Say character A, and this is the sign of correlation of two characters. They must have some differ. They must correlate, must have some differences. So A and B can be said to be different. You can correlate them to be different. So this is another principle. The next principle is it is considered to be an empirical science. So there is no principles and laws like this. It's on the basis of numbers, counting, empirical. Then the sixth character is phonetic similarities. That is number similarities forms the basis of numerical taxonomy. Okay, so let us go to the next part of our studies. So first we had seen that you make taxonomic groups. First we had seen that you make taxonomic group, and so we must understand what certain terms and definitions will come. You must understand what they are. First thing is unit unique characters. So the same Sural and Sneath in 19 SNS I'm calling now. SNS in 1963 they had given unit characters. They defined as taxonomic characters, taxonomic character of two or more states which within the study at hand cannot subdivided. So, what do you mean by this? It means that a unit character has got two states. Unit character, two states. Say, for example, eye color, Drosophila. You have red eye, white eye. So, this character has got two states. One state is red eye, one state is white eye. So, this is an unit character which is taken under consideration. This red and this thing. Or you can say another example they have given is the presence absence of on AWN in a grass pikelet. For botany students they can use this example. On হচ্ছে ধানের শীষ. So presence or absence of an on in a grass pikelet. So, now types of unit characters. What are the different types of unit characters? Now we are not talking about now what are the types of unit characters? First one is called binary character. Now forget about what the character is. Here forget the character. It is we are talking about whether the character is eye color or ear shape or gene sequence or whatever. We are talking only numbers. How many characters you have taken and if these two characters are same or if these characters are different. That's all. So binary character, there are two things. So two states. And it can be recorded as plus means have plus or minus. People write them as 1 or 0. When they make a table, positive characters, those who are similarities, can be made plus, and dissimilarity, it can be made minus. So this can this is by binary character you can represent it. The next thing which we are talking about are we talked about binary character. Let's talk about multi-state characters. So that is two or more forms. Some people write plus plus or whatever, but most of them they write whether if two forms, they write 2, 3, and there is no dissimilarity, -2, -3, +4, similarity +2, +4, or they can write minus or they can write plus. Many plus together they can write them as 2, many minuses but -2. So it's this is how these are multi-state characters. They can be qualitative. Qualitative is they're ranked on equal footing. For example, color of eye, red, white, purple, they are same, equal. Red is equal to white or blue or red. So all colors they are same. Quality. You are talking about quality. And the other is of course quantitative multi-state character. If it is centimeter, 4 centimeter, 8 centimeter, it's not same. 2 is not equal to 4. This is quantitative multiple state character. So let's go to the next board. Now we will be talking about how to make phenogram. So how do you estimate the resemblance between two OTUs? How do you do it? First is in terms of similarity, that is percentage of characters in which they agree. Okay, so in terms of similarities, percentage of characters in which they agree. That is their same characters. Their similarities. And in terms of dissimilarities, it's the same. It's percentage of characters in which they disagree. So there are basically 3 methods which have been devised. So first one is which we will be talking about is the coefficients of association. So there is a formula. So what is the formula? SSM equal to M divided by M plus U. This is the formula. This is also known as simple matching coefficient. Another word is numerical index. Some people call it as also numerical coefficient. Let us take a make a particular table. M is match and IU is unmatch, not matching. Dissimilarity. M is similarity, dissimilarity, and this is the total number of characters taken. So let us draw a particular table. I'm not particularly good at drawing, but let's see. Or maybe I am very good in this. This is an art. So you have characters. The characters, character 1, let it be X, we don't know what. Character 1, character 2, character 3, character 4. Now you have the first operational taxonomic unit, that is OTUI, and you have the second OTUJ. That is the second one with you comparing this OTUI and OTUJ. What you find here, let's do it with different color over here. So you have plus means it has a match. This is minus. So a particular character 1 OTUI is plus, it has got it, and OTUJ does not have it. Now let's go to character number 2. Both of them have this particular character. Similarity we are talking. Then character 3, both of them don't have this character. So it is also similar, they don't have this. And character number 4, this doesn't have and this has. So number of my spelling. So number of matches what we find, this is a match, this is a match, same plus or minus, both of them match. So 2 of mismatches, this is plus minus, this is minus, they don't match. It's also 2. So what is S? This is equal to 2 divided by 2 plus 2. So the simple matching index is 0.5. This is how it works. Let's go to the next part. Next way by which they can be studied is using a very complex formula. You can derive this formula, but I think you don't need to do that so much. Or rather, I would say that I don't want to burden you with all the derivations. It's quite very simple if you study correlation. We are talking about coefficients of so the following formula is used. Coefficient is R of two characters J and K. This is equal to the total number of characters we are studying, sigma, that is sum of xij. I will explain very shortly what this is. Xij minus xi in x. You are talking about j and k, two values. X I minus xk divided by root of, calculate in coefficient variance. Basically, you have to get it through under root. Sigma n xij minus xj whole square, third bracket close, third bracket open, n xik so this is the formula. I is the name of the character. J and K stand for two OTUs under comparison. IJ stands for the value of the character I in unit J. That means the character, say long nose, and unit J is long nose, say J is humans and I is chimpanzee. So value of long nose in operational taxonomic unit J, that is in humans. Value is 1 because we have got long nose. Chimpanzees don't have long nose, so that is 0. So that's how you put the character. The next formula is xik, stands for the value of the character I unit K, and I and xj, it stands for mean of all the characters in unit J and K. Say J is humans, okay? So it's the mean of all the size of the noses of all the humans. And N is number of characters being studied. So we come to the last part, that is cluster analysis. And most important of this cluster analysis, in my notes you will find more easy small things which you also need to study. I am not teaching, otherwise we will go continue till the night, and I don't think you people would like it. I have no problems. Okay, let's go to the, what do you mean by phonetic clustering method. So clustering means bringing similar OTUs together and putting dissimilar OTUs in different lines. Basically what you're doing, you're trying to draw a like in cladistics, but we are using certain other methods. So the most popular used is phonetic clustering method used is nearest neighbor clustering method. So it is also known as single linkage clustering. So phenograms are constructing joining OTUs and groups on the basis of their most similar members. Phonograms constructed by joining OTUs, or say OTU A species A and OTU B species B, joining OTUs on the basis of their most similar members. Yeah. So similar, more closer together. So let us make a similarity matrix. Let's put data on the basis of similarities. Let's have a diagram. So let's draw these blocks again. So A, B, C, they are characters. OT A, B and C use not characters. Let's draw it separately once. You have there, say this is 0.40. Similarity percentage. Out of 10 characters between A and C, 4 characters are similar. So 4. Now A and B 0.63. So out of 10 characters, 6 characters are similar. So 6. A and A, of course, all characters are similar. So 1. Now B and C have similarity 0.3. That is, out of 10 characters, 5 characters are similar by 10.53. And B 1. And of course, we know that C and C 1. The other way around, you get the other data coming over here. So you have this data coming back over here. Now, on the basis of this, you see B and A very close together. So your diagram will be A and B 0.63, and then B and C 0.53, B and A is 0.0, and C is 0.40. So A and C 0.40. So this is how this is drawn. So this is how you make a nearest neighbor. So the nearest neighbor is 0.63. With this, I am ending my class over here. So I stop the sharing and come back to the screen. Do you people have got any questions? I will be happy to answer. Question ache karur?
No, sir.
Okay. You can write to me on the Google Classroom if you have any questions. I will be happy to answer. Don't write it on WhatsApp because it's very difficult typing. So with this, then I end my class over here. In the next class, we will be talking about cladistic analysis. Okay, bye.